Hi everyone. So today we're going to do an introduction to the section on sensation and perception. So all this sort of the introductory stuff. The next lesson will be on the functional parts of sensational, like the eye and the nose, and the theories that go along with it. So let's get started with an introduction to it all. So my first question to you today is, how does our brain receive messages? Based on this section, how does our brain receive messages? Now, some of you may say transduction, which you would be right. And through transduction, we need to use our senses. So we have to use our five senses. And that's where that physical energy is going to come from in order for us to use transduction. Besides vision, hearing, touch, smell, and taste, we also, remember, have two senses called kinesthetic and also vestibular. So kinesthetic is your body awareness, like your awareness of where your body is in relation to other things and also itself, like where you are. A good example of this is when people play sports or play basketball. So if you've ever watched anybody who knows how to play basketball really, really well, you'll see them kind of dribble down the court. They are looking straight ahead, and then they sort of pass the ball out to the right. They sort of know where the person is to the side so that they can get a pass that's kind of sneaky to the other team. If any of you have been sitting at your desk and you reach over to get your phone, but you don't actually know that your phone, you don't look at your phone, you actually reaching out and touching would be kinesthetic sense. Vestibular is, your space and direction, and when it's off, you really know. Like when you're turning upside down on a roller coaster, your vestibular sense is off because you're trying to figure out where you are. That happens when you get tossed around in the ocean on a wave. It also, you can really feel that if any of you have been to Universal and been on like the Hulk ride or Disney and went to the rock and roller coaster where it shoots you into the tunnel or through the tunnels, you can really feel your body, that sense of speed and direction, and your vestibular sense kind of keeps, makes you know what's going on. Because of it, there's in your ear, you have a connection to the semicircular canals that are next to the cochlea, and that is why when people get vertigo, it's connected to the ears. So both of these are really important for us figuring out how to move and navigate the world. So playing with a ball would be your kinesthetic and vestibular sense, and walking and crawling are all going to use those as well. So what happens when you lose one of your senses, or there's an issue with one of them? So if, for instance, you weren't able to see, what would happen because of that? Well, you would rely on your other senses. And if any of you know anyone that is deaf or blind, you know that if someone is blind, their sense of hearing is amazing. And that's because they've had to really heighten one of those senses because something is also gone. Remember that the two senses that we use the most to navigate our world are hearing and sight. And so when those are gone, we definitely have this other senses that are going to be used to be able to figure out what's going on in our world. Okay, so I want you to think about, whether or not you would pick one or the other. Would you rather have your sense of hearing or smell? And so I think most people would pick hearing because smell is something hearing somebody is much more important than maybe even smelling something. But if we looked at it and we said your sense of taste or your sense of sight, well, that might still be easy. I still want to be able to see things, but I'm okay with not being able to taste food. Somebody out there may say, no, I want to taste food. I would rather get rid of my sight. Your sense of touch or sight. So maybe sight would win over touch for sure. But if you look at your sense of sight or hearing, that's when you certainly get a divide. If you had to pick between those two really important ones, there would be difficult to do that. And so this whole chapter is really cool because it brings in sensation and perception. And our perception is not perception necessarily of what people think, it's perception of what we're seeing and what's going on in our surroundings, which is really cool. And so this brings in the Fraser spiral, which illustrates the difference. Our perception is of this figure is that it's a spiral, but it's an illusion. The sensation is that we look at the shapes, and we're looking at the different colors and so forth. But our perception of how that's being processed by our parietal lobe is that it is a spiral, because the illusion is that those shapes are put in such a way that it creates this illusion of actually spiraling and falling down into a hole. So what is, in terms of basic principles, what is the detection and basic sensory experience of environmental stimuli such as sound, images, and odors? We call that sensation, and that uses your organs, the parts of your body that we'll talk about, like the eye and the nose. What's the integration, organization, and interpretation of that sensory information in a meaningful way? That's perception. It's the brain determines what something is from, and uses that sensory information to do that. It's a single process that works together, and that's why that's Fraser spiral. We really see and use sensation and perception together to make sense of our world. So one of the videos I want you to watch is that this unit includes this really cool stuff. Watch the first additional video after this, and you can kind of see a couple of illusions and so forth that are really cool. And your brain plays tricks on you for sure. Okay, what does this picture below explain, or how does it explain the basic principles of sensation? So we have a central nervous system, we have a brain and a spinal cord. You can see some neurons sending down some like little impulses, and they're touching this cat. Those sensory receptors or scouts are kind of figuring out what's going on. And then the sensory nerves in the peripheral nervous system are going to transmit that what the scout has detected, and so neurons will be talking. And then it goes up to the brain, where then impulses reach the cells of the brain, the command center, and has this perception that the cat is fuzzy. So this is all the sensation in terms of the results of neural impulses. Neural impulses are transmitted to the brain from those sensory nervous or those sensory receptors or specialized cells. And all of our senses are stimulated by some kind of physical energy, which is what we'll go over. What's the different physical energies that your eyes, your nose, your taste buds are stimulated by. And it will turn into electrical impulses that then are transmitted via neurons to the brain. This involves all of the senses, not just one. In this particular one, we have touch, we have vision, hearing, and smell. You know, you could hear the cat meow. Obviously, the vision and the touch are going to, figure out it's fuzzy. And then maybe you could smell the cat, depending on how smelly it is, because Phoebe does think things are smelly. Okay, what is transduction? Well, that's the process of taking that physical form of energy from your senses and then coding it into a neural signal that then can be processed by your nervous system. And again, chapter 2 is really important because we wouldn't understand what a neuron or a neural signal would be unless we did that first step and learned about chapter 2. So the stimulus energy must be in a form that is detected by the specific sensory receptor cells. So light is not going to stimulate your taste buds, right? It sounds funny, but it has to be a specific energy. And the reason why your taste buds are not stimulated by light is because there's certain receptor cells that are receptive of certain energies, and that's not one of them. So like stimulus thresholds for action potentials on a neuron, a stimulus for the senses needs to be strong enough in order to activate those certain cells, in order for that to have some kind of reaction, okay? And there you can see the light waves are used to see the butterfly. That transduction is going to be done within the eye, and within those receptor cells that are in the eye. That neural signal is then sent to different places on the brain. So we'll get into more detail specifically with each sense of how that happens. So there's certain thresholds of sensation that was gone over in your book. What's the difference between absolute indifference or just noticeable thresholds? Well, absolute threshold is the smallest possible strength of a threshold, a sense to be detected half of the time. So half of the time they kind of figured out like this is the measurement of that. So it's the smallest possible. It says So if you turn up the radio and then all of a sudden it's there, you know, that's the smallest possible strength in order for you to hear it half of the time, because, you know, not everybody's going to hear something the exact same time for everyone. So the way we measure absolute threshold is by using a method called signal detection. That's another vocab word. We use signal detection. And so you're presenting a stimuli in a variety of different intensities. And then how they figured out that signal detection for absolute threshold is by taking research participants, and they determined the level in which he or she could detect given that sense that they were shown. So a demonstration, a special ringtone that's only audible for younger people. So one of the second video I want you to watch is really, really cool. And I wish we were in class together to do this, but try it at home with somebody that's older, like a parent, okay, and press the video, and then both of you kind of pay attention to when you can't hear the ringtone. And what it will do is it'll start really low, and then it'll get really, really high pitched. And what you'll find is you as a teenager can hear the higher pitch, and all of a sudden your parents are not going to be able to hear the higher pitch because of their age. And that does change with age, that you can't hear as high a pitch of sound and so forth. So try that experiment at home with somebody. So this is how we know all this. Those research participants found out absolute threshold of vision, for instance. So vision, you can see a candle flame 30 miles away on a clear night. And they did that at least half of the time. Those participants could see that candle flame 30 miles away. Hearing, a watch tick 20 feet away is the absolute threshold. So they just kept backing people up until they could hear it. Taste, a teaspoon of sugar and 2 gallons of water. It's the smallest amount that you need. 1 drop of perfume in a 3-bedroom apartment. That's pretty amazing, but that's the smallest amount needed to do that absolute threshold. A bee's wing, whoever does these things, right? A bee's wing falling on your cheek from the height of about a ½ an inch, that you can actually feel it. And these were all done a long time ago in studies by Eugene Gallagher. Okay, so then what's difference threshold, or just noticeable difference? What's that? It's the smallest possible difference between 2 stimuli. So the other one, absolute threshold, is with 1 stimuli. This one is with 2. Now it's going to be the 2 of the same sense. It's not going to be hearing and vision. It'll be like touch and so forth. And this is also called Weber's law. All right, and that's where we detect it. And again, that's half the time. So they did this with people and so forth. And it's going to be half the time, so that it's not all of the time that this would happen, but most of the time, right? So the smallest possible difference between 2 stimuli. So this is when you can find the difference between 2 things. So for instance, if you are holding 2 weights, okay, it's harder for your friend, based on Weber's law, to tell the difference between a 10-pound weight and an 11-pound weight, because the 10-pound is a lot stronger. That first initial stimuli is really strong. And so just adding a little bit isn't going to do much. But if you were to go from 1 pound to 2 pounds, you would be able to see the difference. There would be a much higher just noticeable difference there, because the initial stimulus is not as heavy and so forth. So for instance, at the bottom there, you can see that graph. If the background intensity is less, the time to cross the threshold is less. Okay, so the background intensity is less. The time where you to cross that threshold where you can tell the difference is also less. So you can tell the difference sooner with that. The stronger the stimulus, the greater the initial stimulus, the greater the stimulus needs to be in order to reach the threshold. So instead of going from 10 to 11, if we went from 10 to 20, we would be able to tell that difference. But what they would do is go 10, 11, 12, 13, 14, 15, and half the time, you know, it maybe for somebody else it's 18, but in half the time, like, what's the actual difference? If you're holding a 10-pound weight, what's the next weight that you need to be holding? And again, that's all touch. Okay, so they do that for different senses. So it's just like this. If you are looking at the price of chocolate bars, it goes up, right? If the price of the chocolate bar goes up 25 cents, we may notice it if you're a regular chocolate bar eater, 25 cents might that. However, if a car goes up $4,000, because cars already are high, you might go, oh, 4,000, that's not that much. But when something is smaller, like a chocolate bar, and it goes up from $1 to $1.25, you will notice that because, you know, it is a much smaller initial price than a car would be. So that's Weber's law. Why half the time? Okay, so we've talked about that. People are different in their minimal levels of stimulation. So like I said, you know, somebody with the weight it may take them from 10 to 13. Some might be 10 to 15. Some might be 10 to 18 and so forth. So that's why we do half the time. Now, the third video you're going to watch was going to show you what absolute or difference threshold is going to be, and a guy is going to be showing you a demonstration in a car. So I would suggest watching that to show it in action, like with hearing, okay? Okay, what kind of interference do we have with stimuli? Well, attentive processing, which we're also going to be talking about next chapter, we focus on one stimuli at a time automatically, okay? So we can get very distracted at times. It's very hard to multitask, but we can multitask. But we tend to focus on one stimuli at a time, so one sense at a time for the most part when we're trying to pay attention to something. So what happens with the Stroop effect? Okay, so I'm going to do a little experiment with you that I can actually do with you. All right, and so what I want you to do is as I show you this chart, this is called the Stroop effect. I want you to read the words as fast as you can. Read the words as fast as you can. Ready, go. Now, as you notice, the top line, the blue and the word blue correspond, right? Orange, green, red, purple. When you start getting to the second line and you go red, purple, blue, orange, green, I actually did that pretty fast, you're going to notice that the red does not match the color, right? You're looking at the word, but the color is blue. And so sometimes people, it takes them a minute just to grasp that because they are looking at the visual part of it, but then also, you know, when you're thinking about what that word is, it's not matching. So that's called the Stroop effect. So we have interference with our stimuli at times. With another stimuli, it affects the processing, right? I had an example of circle and X on the page. I'll try to give that to you next time in order to show us a couple things about stimuli. Okay, why would somebody say, I don't smell it anymore? What is this person experiencing? I want you to think about when you walk into Chili's, if you've ever been to Chili's, and then by the time you leave Chili's, why is it that you don't really smell Chili's until maybe you get home, put your clothes away, and then the next morning get up and go, oh, that's Chili's, right? Because Chili's always makes your clothes smell. What is this person experiencing? So the person is experiencing sensory adaptation, and this is a really cool thing. We become accustomed to stimuli, and it makes us not become overwhelmed by constant stimulation of that sensory information. So one example at the bottom you see there, sensory adaptation period. So put your hand in hot water and cold water, and then you've got lukewarm water. The perception after you get used to the cold and the hot is when you get your hand in the hot, the lukewarm is going to feel cool, right? Because you've gotten used to what hot's going to be like. And then with the cold water, that lukewarm water is going to feel warm, obviously. And then, you know, like I said, it's all about like your senses. All of a sudden you don't notice that something's going on. So let's look at some examples of that, like jumping into a swimming pool, right? Jumping into the lake, whatever it might be, if it's starting to get cold, right? As soon as you jump in, it's really, really cold, right? And then after a while, you get used to it. Oh, it's not bad once you get in, right? That's what people are talking about. It's that sensory adaptation of jumping in and then your body getting used to the sensation. And again, your body is going to stop giving those neural signals so that it doesn't become overwhelmed by it because you've had that sensation. You can, you know, the temperature of the pool or the lake is what it is, and then you're moving on. It's like your body's moving on from that and concentrating on another sense so it doesn't become overwhelmed. So sensory adaptation is really interesting. Think about sensory adaptation with your clothing, right? When you put clothing on, You can feel that when you first put it on in the morning, like like I put my scarf on today, it was so cold out, and I have my nice fuzzy sweater, but after a while I don't even notice that this scarf is on. I don't feel it like I did when I first put it on, or my clothes or my shoes or whatever it means. So that's a good thing, because if you could feel your clothes all day, it might drive you nuts. Think about, I know you guys, it's been a while since you've been in a classroom, but when the projector is on in a classroom, maybe at first you kind of notice it, and then after a while you don't even hear it anymore. People who have scratches on their glasses, after a while they're not going to see those scratches. It just kind of gets, it's kind of just part of, their vision at that point. This is a good example too. I do this all the time. Think about when you're driving home and you have music in the car, right? Or if you're playing, your earbuds or whatever, and you're driving home, you're playing that radio at a certain volume. As you keep driving, don't you tend to turn the volume up, okay? Then you turn the car off, you go inside, and then you're done. You get up the next morning. What happens the next morning when you get into that car and you start the radio again? It's like, whoa, what was I listening to? Like, the music is so loud, and that's because your volume, you're starting to get sensory adaptation, and you think, other things are making it kind of lower, or the song's lower, or what it might be. No, it's because your hearing is getting that sensory adaptation, which is why we need to be careful about turning our music up too loud, because we can damage our ears if we don't pay attention to that sensory adaptation, okay? So the stimulus is constant and unchanging, and we become less sensitive to it, which is why, and we have less neuron signals coming in here. So remember your earbuds. Listen to them first, before you put them back in. Make sure you put them here and see that, the volume was down from the last time, so you don't blast your ears, and make sure you don't keep turning up that, because it will affect your ears. So our sensation and perception, our experiences are processed by our brain in two different ways. And this is two ways that they talked about, the bottom-up process and the top-down. So when we're tasting food, or we're looking at a band or a type of music that we like, we do things in a certain way. The first time you eat something or you hear a band, you are processing something from the bottom up. Bottom up is like, I have nothing to base my experience on, and I'm building my perception of something, okay? If I am going to do top down, that means I've already established a bunch of experiences about that food type or whatever, and now I'm tasting something, and I'm going to look at, and I'm going to be perceiving it based on what I already know, okay? So bottom up, I'm building my experiences, so I don't know what I'm, about anything. Maybe the first time you tasted a vegetable, okay? So somebody who's a much younger would go through bottom up, okay? Top down would be somebody much older, using it to sort of determine what's going on and so forth. All right, so those two ways that we perceive some things. So let's do this, okay? Let's do a little experiment with this top down and bottom up, okay? So what I want you to do when I show you this quote is I want you to read it aloud. Don't think about it, just read it, okay? Ready, set. Okay, now read it again. Did you notice that there are two thes? I love Paris in the springtime is what most of you probably read, okay? A person learning to read, however, is going to notice those two thes because they are bottom up. They're going to be very deliberate. But for most of us, because we know how to read, our brain is like, no, the brain is, that doesn't make sense to our brain. So we get rid of that the and put the just one the, okay? Even though, and it's kind of cool because they're on two different lines, so you sort of don't write, a beginner reader would read, I love Paris in the spring. But for us, our brain just kind of skips over that the, because with top down, we know that doesn't make sense, okay? So that's pretty fun. Some of you may have already done that before. Okay, and then we talked a lot about subliminal messages, okay? And what is subliminal perception? And is it perception or persuasion, and how does that all work? So one of the things about that is there's a detection of stimulus that are below the threshold of conscious experience or awareness. So subliminal messages are with is in our unconscious and it's below that threshold that we'd actually notice it. Do they work in advertisements and so forth? Most of the time, the research has shown us that subliminal persuasion does not relate to customer decisions. So somebody putting subliminal messages, like the man who in the movie theater was, putting pictures of Coke and popcorn on the screen or words and so forth. That is not, you're not, unless there's something else going on, that's not going to just all of a sudden make you buy Coke or popcorn. There has to be other factors that are involved. People can perceive through their unconscious though. That's a definite. Sometimes we don't even know we're processing something. And when do they create an effect, right? Is there an effect on there? And the answer is yes. The important word in this section of the book is the mere exposure and effect. And I'm going to tell you that there's a lot of times on the AP exam, especially in the FRQ, that they will put mere exposure effect. I've seen it a few times. This is a repeat exposure to a particular stimulus. If you are repeated exposure to a stimulus, you increase the likelihood for that stimulus to be liked, okay? That's why you give kids vegetables and you keep giving them the vegetables because eventually they might like that vegetable. Okay, you don't just shut it off and say, oh, they're never going to like vegetables. Okay, it is something that they can eventually like because it's repeat exposure. This can happen even if the stimulus is subliminal. So for instance, participants exposed to a shape in an experiment with subliminal images, okay, they were then asked afterwards to pick a shape and they picked the one that they were exposed to in the subliminal image, okay? So they have shown that that perception that you are perceiving something in your unconscious can be influenced by the mere exposure effect. Now, reasons it would work, okay, why subliminal messages would work. It's not just because the message is there. Okay, most of the time it's not. When the message already has to be relevant to what the observer's goals are. So if they're trying to get you to drink Coke and they're showing you pictures of Coke in the intro to a movie, you would have to already be thirsty, okay, in order for you to buy the Coke. That's what they found in research. Attitudes and emotions can be influenced, okay, through subliminal things. So in an experiment, they were shown subliminal images of faces. And then when asked to rate faces, observers who had seen fear faces actually said that they were unpleasant. No matter if the face looked unpleasant or not, or was supposed to, they found that those were they were unpleasant because the subliminal messages had made their view of faces be unpleasant for that time period. Number 3, only when the individual who are just predisposed to behavior are unaware of the stimulus. If someone is aware that of the subliminal stimulus, they're not going to be swayed by that. Okay, so for instance, an experiment did pleasant and unpleasant scents were paired with faces. So pleasant and unpleasant scents paired with faces. So if the participants were unaware that scents were actually involved, they rated their responses to the pleasant or unpleasant faces. If participants were aware of scents in comparison to the faces, likability and odor pleasantness in relation to the faces disappeared. So it didn't have any correlation there and so forth because they were aware of the scent. So it has to be very slight. So in this particular, we have an advertisement, and can you guys see what the subliminal message is? Can you find it? And then what sensory modalities are involved? So obviously visual is there. Okay, I'm not going to tell you just yet. I'm going to have you look at it. Visual is there. And we can almost to a degree, depending if we've eaten something like this, like imagine kind of biting into this juicy fried chicken sandwich with lettuce. I mean, maybe it's got some mayo on there and you go, ooh, that tastes good. And your mouth starts to water and so forth and whatnot. So does anybody see the subliminal message? There are actual dollar signs in the lettuce. There's a couple of them, but it's so slight. And what it's telling you is this is a cheap sandwich to have. It's 99 cents. And, along with it being great to eat, it's also very cheap. So you would also have to be very hungry to want this as well, just because the subliminal message or the subliminal visual is there is not going to make you buy the sandwich. You'd have to actually want the chicken sandwich and eat it and want to, you're hungry. Okay, so what are some studies that they've done with persuasion? For one, a couple good studies. So the first one in 1987 studied for mirror exposure effect, and the study found that subliminal exposure to abstract shapes in photographs of people lasts as little as 4 minutes, and it led to greater preference for those shapes. So within 4 minutes, people would actually get to have from mirror exposure would actually, have an effect on them, 4 minutes or less, as little as 4 minutes, I'm sorry. And so that's a pretty significant, doesn't take long for that mirror exposure to have an effect on you, as it showed in this 1987 study. 2006, they did the Lipton iced tea study. There was subliminal priming of actual Lipton iced tea. And so it led to a greater intention to drink the iced tea, but among those who were only thirsty, as we said before. 2017, only people already planning to donate to a charity and who had already held strong, consistent values for giving to charity, actually, if they were primed to give, would actually donate money. So it has to, again, go with the values of the people and the observers. And then 2015, thirsty participants were more likely to choose a primed brand when offered for free, but not when they were but not when there was a brief 15-minute delay between the brief and the prime and the choice, okay? Showing that mirror exposure effect actually will decrease. It happens very quickly, like that 4 minutes, but also if you have that delay, that exposure will go away and you'll be less likely to respond to something subliminally primed to you. And primed means, I'm giving a suggestion. I'm giving a suggestion, and now you're going to take it. And I'm priming you to make that decision based on something I've said ahead of time. Okay? Okay, and then lastly, top-down processing and subliminal perception. So when we have top-down and we're processing something in terms of subliminal, we are influenced by culture and our experiences, as top-down assumes. But a part of that is our culture, and our expectations are influencing our perception of a stimulus. And it happens automatically out of consciousness. The way we perceive something, we don't think about perception. That's not the way it really works. You don't have to be consciously aware or pay attention to a stimulus to have in our environment for them to be perceived, okay? So the last video I want you to show is, and it may not work, I'm not sure, depending on, is to look at, I would normally play this in class, and what this is when you click on this last video is it's a website that will show you songs. And so what I normally do in class is I play the song and I play it backwards. And so you can't tell what the song is, okay? Until I actually tell you what the song is, and then you can actually kind of hear it and so forth, because you've been primed to listen for that particular song. But for the most part, when you first hear the song, you have no idea what it is. But then if I tell you and I play it backwards, you're like, oh yeah, I can kind of hear it now. So it's that sort of idea of being primed and so forth. Okay? All right. I'm sorry. Two more things. Sorry, I forgot. I thought this was the end. ESP is the last thing. And I wanted to make sure I got all the boxes covered before tomorrow when you do your functional sensation video. So do you believe in ESP? So we talk about that in class. Like, do you believe in it? I have a clip of a lady, the last clip, where she's somebody who's clairvoyant and has extrasensory perception. Okay, and she talks about what that experience is like for her. And it's very, very short, so you can kind of get an idea of somebody who actually is talking about it. So there's various things. We talk about, whether or not people believe in these things or not, okay? So telepathy is one thing, and that's communicating using your mind. So we don't talk, and we are using our minds, not our mouths, to actually communicate. Clairvoyance is sensing an object or an event has happened somewhere else, okay? You need to know these, okay? You need to study the definitions of these. Clairvoyance is like, I have a sense that something happened to my dog when I was at school, and when I get home, I find out something actually did. Psychokinesis is like Luke Skywalker and in the Force, like moving an object with your mind. Okay, so think Luke. Precognition is predicting future events, and that's what this lady can do. She can tell when things are happening, but also predict future events as well. Around 50% of Americans do believe these actually do exist, but there's other explanations that were listed in your book that could explain these things as well. And this is where psychology steps in. They don't really believe in those other, in telepathy, psychokinesis, any of that. They leave room for skepticism, but they say that, there has to be a healthy sense of skepticism, even if there's evidence, and they want more evidence in order for this to be studied. So this is an area of psychology that isn't vetted yet or isn't decided on all of this. So for instance, an explanation used by psychologists is that something could happen by coincidence. So with clairvoyance, I think something's happened to my dog, and then I get home and something has. It's just coincidence that I had that feeling and something happened. So that's how they explain that. Fallacy of positive instances. So remember coincidental events, remembering those can confirm our beliefs, and we forget about all the other, hunches that weren't confirmed. So I'm sitting at school and I had, several days where I thought something was going to happen to my animal and nothing did. And then all of a sudden it did, and I go, oh, I must be clairvoyant. So you get all of the positive, the fallacy of positive instances. I only had one positive instance where that happened, but it's a fallacy because most of the time nothing happened to my animal. So I'm kind of, dispelling that, Also, research designs, unintentional research cues and non-replicated studies and data that had been done with ESP over time, and so they would discredit some of those studies that showed that ESP is actually a thing, and they were saying, that it's because the data is not there, it's a fallacy that we have ESP there. There was one particular procedure, the Gasveld procedure, that did show a slight something proved that people were communicating outside of a room. So that the sender of the message was in one room trying to communicate a picture to someone in an opposite room. And basically what they used was white noise with headphones, and they covered the eyes with ping pong balls. That's what the picture you see in your book. And people had mild hallucinations that matched, the pictures and so forth. And they went, oh, they're communicating with telepathy. But that was very slight. And so again, non-replication and data and things like that, some of those studies that people do in psychology has shown that ESP is needs more evidence. We need to have, we need to have some skepticism and have some real good research done out there. And maybe one day one of you will do that. Okay, guys, have a great day. Look at those videos on Canvas before to get some extra kinds of things and do your assignment today. Okay, bye.